This is an AQA GCSE chemistry question. It's from Trilogy Paper 2019 and it is a higher question. Going to be looking at the periodic table, chemical calculations and bonding. Going to recommend you pause, try each section and then review later. So here are parts A and B, part C, part D, part E, and part F. In total, an 11-mark question. So let's go back and review. The question is about elements in the periodic table. What order did scientists use to arrange elements in early periodic table? The key here is early periodic tables, and it's atomic weight. We use mass number now, but they used to use atomic weight. We've got to get that distinction into understanding. In early periodic tables, some elements were placed in the wrong groups. Mendeleev overcame this in his periodic table. How did he do it? Well, one of the key things he did was leave gaps for elements that had not yet been discovered. Then, in future, when they were discovered and found to have the properties that he had suggested they would, they slotted into his table. The other option is looking at the example of potassium and argon that would be the wrong way round if they were in order of mass number, but he just swapped them over. So that was also worth a mark on this one. Part C, the table shows the boiling points of fluorine, chlorine and bromine, and we can see they're all pretty low. Explain why the boiling points in the table are low. And we are looking here at some of the key bonding information that that was learned about covalent structures, particularly molecular covalent structures. In each of these we have F2, Cl2 and Br2, but we don't break the covalent bonds when we boil them. We overcome the intermolecular forces, and the intermolecular forces are weak. And if the intermolecular forces are weak, not much energy is needed to overcome them. But within that table, there is a trend. It does go up from fluorine to chlorine to bromine. Why? Well, the molecules are getting bigger from fluorine to chlorine to bromine as you go down the group. And if the molecules are getting bigger, that means the intermolecular forces are getting stronger. And if the intermolecular forces are stronger in bigger molecules, more energy is needed to overcome them. So the boiling point increases. On to part E. Why is neon unreactive? Give the electronic structure of neon in your answer. So neon has an atomic number of 10, mass number of 20. So 10 electrons. The first electron shell holds 2. The second electron shell holds 8. So the electron configuration is 2, 8. So why is it unreactive? Well, it's got a full outer shell already, so it doesn't need to lose or gain or share electrons to get a full outer shell. And finally, part F, how many grams are there in 1 gram of argon? We're told the relative atomic mass of argon is 40. Now that means that 1 mole of argon is 40 grams. We also know that 1 mole of anything contains 6.02 by 10 to the power of 23 atoms or molecules of it. So we're going to find out if there are this many in 40, there will be a 40th of that in 1 gram. So 1 over 40 times 6.02 by 10 to the power of 23 gives you a value of 1.51 by 10 to the power of 22. And that brings us to the end of the question.